Section 8-4, Key Concepts. We're going to look at these two lines graphed on the same graph. The name of this first equation here is y equals positive 1/4 x plus 2. Now that's positive, okay? I've listed it over here. My slope is 1/4, that is your rate of change. And your initial value, which is your y-intercept, is 2. So from 2, we had to rise 1, we had to run 4 to find a point, another point on this line. Looking at my second line, its y-intercept, or its initial value, is going to be at -1. And what is my slope? Well, I had to rise 1, run 1, so my slope is 1. So this line has an equation of y equals x minus 1 with an understood 1 in front of x. Both of these lines have a positive slope. Now, since their slopes are different values, we know these two lines are going to touch. They're going to intersect. There's going to be a point of intersection. So right here would be my point of intersection where the two lines touch. So therefore, these two graphs represent different rates of change. In other words, these two lines have different slopes, and they also have different initial values, which would be the different y-intercepts. In other words, they touch the y-axis at two different places. Let's look at our next situation. This line is slanting upward with a positive slope, passes through the y-axis at -1. Your slope here would be rise 1, run 1, rise 1, run 1. So your slope is 1. This is the equation of this line. Y equals to x minus 1. Slope of 1, rate of change is 1, and your y value or y-intercept at your initial value is -1. Looking at this line, it is distinctively going downward. It has a negative slope. It passes also through the y-axis at -1. So I have -1 as my y-intercept. What is my slope? Well, I had to run down 1 and to the right 2 to find another perfect point. So down 1, run 2. So your rise would be -1 and your run would be +2. So I said that wrong. Your rise would be -1 and your run would be +2. So I've got a slope of -1/2. I said that wrong. Let me go over that again. Rised -1, okay, that'd be the same thing as putting -1 on top, and running 2, 1, 2 would mean to the right 2. Either way, my slope is 1/2 and it's negative. So whether you got your negative on the bottom or the negative on top, that's okay. And then you have your x. So this equation, y equals -1/2 x minus 1, is going downward. You see that these two lines have the same initial value. They have the same y-intercept. It would be 0, -1. That's the y-intercept. Notice that both of these b's are the same. Y equals mx plus b. This is your initial value, or your b, which is your y-intercept. So these two lines have different slopes, but the same initial value, which is your y-intercept. And you see they still touch at a point. When your lines have different slopes, they're going to touch at one specific point. And let's look at the last situation here. We have two lines that never touch. You see two lines that are equal distance apart. They never touch. These are what we call parallel lines. Now, parallel lines have the same slope. So anytime you're looking at two equations that are in the form of y equals mx plus b, if they have the same slope, then they're parallel and they're never going to touch. So looking at these two equations here, they are both in the form of y equals mx plus b. You see both of their slopes or their rate of change is the same, and if they're the same, they're parallel and they will never touch. Now their y-intercepts are different. This one has a y-intercept of +2, or an initial value of +2. okay? If you rise down 1, it'd be coming down 1 and to the right 2, you'd find another point. So that's where I get my slope negative 1/2. This line touches the y-axis at its initial value of negative 1. And to determine my slope, to go to the next perfect point, I would come down 1, negative 1, and run positive 2. So that's where I get my slope of negative 1/2. So this situation, these lines have the same rate of change, which means the same slope, but they have different initial values. They have different y-intercepts. So the graph crosses at the two lines touch the y-axis at different places. So this is an example of parallel lines. They have the same slope, but different initial values.